Hi, folks. So today we're going to go over a little bit more in depth with our data structures. So we're going to start off with a review on arrays, or more like a revision for me, because what I figured out is that in C Sharp, as opposed to Java, you can actually put more complex things into an array form, like transforms, like I said. But as I said before, you can only make this much of them. So if I wanted to make 100 of them, make it that large, it only gets to a certain length that you set. So if I created a loop that defined, let's say, placer, I meant to put this equals something, basically, this wouldn't work because it's outside of the norms, the outside of the 100 that we set for it. But my linked lists that I showed you are infinitely expandable, and it's a lot more useful for the kind of things we're using. Except it's going to be a little bit harder on your programs. So it's going to be a little bit slower. But since we're just using one, maybe two at some point, it won't be that much of an issue because on most computers can handle it. Now, right now, I'm going to talk about stacks and queues. Stacks and queues, I have them filled with transforms, and I named this one stack because, in order to keep everything simple, the stack class is capital S stack, and naming something is just a regular stack or whatever you want to name it, and then you have to do it exactly like this, similar to the linked list. So the way a stack basically works is that you enqueue, so let's say not queue, you push and pop into a stack. Dot push, and then you put in parentheses what you want, like position 0 or position 2. And you can do this over and over again so that it fills each element of the stack, and this is infinitely expandable. However, when you stack dot pop, and this thing has no arguments because it just pushes it out, this puts on whatever on top of a stack. A stack is called a stack, as I will demonstrate, because I will show you in a nice drawing. I'm good at that. Because there are elements on top of each other, like so, on a stack. Whenever you push an element to a stack, you draw a new one. But when you pop it off of the stack, and it goes from the top. So it goes first in, first out. So if you had a stack with only one element right here, you can push it in and then pop it out. And if you have a whole bunch of elements like right here, it'll reverse when you all pop it out. So all the elements you push in go in one order, and they pop out in the reverse order as they come in. And this is useful for a number of things, like the undo buttons on anything you do. But since there are redos of undos, I'd probably use a linked list. But when it comes to simple data structures like the stack, I'm pretty sure it's pretty easy to grasp. Now, the queue, we probably all heard the word line used before, but another word for line is a queue. And a queue is basically something that you put on, just like a stack, except it goes in and out in the same order you put it in. So I will show you. So basically, if you wanted to put a queue, you just draw a few things right here, and they're in a line. And since I put this one in first, the first one to come out is going to be this one, and the last one to come out will be this one because I pushed it in last. Now, there's a different word for doing this, but a very similar way of pushing and popping, like a stack, but it's called queue and NQ and DQ. So I did QUEUE dot NQ, and it's right here. And when you NQ something, it has an argument, like position 2. I just like position 2, really. And when you DQ it, you q dot dq, and this one has no arguments. So to review, a stack pushes an object and it comes out in the opposite order you put it in when you pop it. A queue enqueues an object and it comes out in the same order you put it in, except you can do a number of things with it as opposed to a stack. With a queue, there's two main types. A linear queue, as I will show you right now. I meant, well, this one goes in a line, and it comes out in the same order it came in. It goes straight, like a linked list almost. Except when you want to do something a little bit more ingenious, like let's say if you had a wheel or a knob that turned a specific amount, like on a locker lock, for instance. You could create something like a circular queue. And that basically means whenever you enqueue an element, after you dequeue it, you enqueue it again, so it goes back to the back of the line. So I will show you in a nice graphic. So let's say if you have 3 items. If you push this item, if you dequeue this item, it would go out here to your output. But if you requeued it by queuing it, it goes back to the back of the line. And if you do this enough times, you have a cycle that goes from one end to the other. And my drawing is amazing, by the way. So as you cycle through elements over and over again, it basically works like a wheel. And that's useful for a number of things you could think of. So in a big review thing, because I know I'm going rather quickly through all of this, linked lists are definitely your best friends when it comes to doing something you don't know how long it's going to be and keeping it in a specific order by the element at. With arrays, you have to work within the amount of elements that you set in the beginning. If you don't know how much that will be a problem. But it's a lot more efficient if you know how much you're going to use. And finally, stacks and queues are 2 different ways of arranging the same kind of data, except in a specific way, meaning that it's either before in the same way you put it in, or the opposite way you put it in a specific way. So I hope that cleared up a few things, because you'll definitely be using a lot of these data structures in order to do the game. So if you have any questions, be sure to ask me. Thank you. Bye.